A meta-analysis of 47 studies examining sedentary behavior in adults found that prolonged sitting was associated with a 24% increase in all-cause mortality, a 91% increase in cardiovascular mortality, and a 17% increase in cancer incidence. And the finding that makes this particularly important for adults who already exercise, these associations were largely independent of physical activity levels. People who met the recommended weekly exercise guidelines but spent most of the rest of their day sitting still had elevated mortality risk. The implication, sometimes called the active couch potato phenomenon, is that exercise and sedentary behavior are distinct health variables. One does not cancel the other out. After 55, understanding this distinction may be one of the most important and underappreciated behavioral interventions available. This is a finding that tends to produce a specific and uncomfortable reaction in adults who have built a disciplined exercise routine. The person who gets up at 6 in the morning, completes 45 minutes of aerobic training, strength trains twice a week, and feels justified in being sedentary for the remaining 10 hours of their day is the target audience for this research. The BISPOS meta-analysis is telling that person, and this is the message worth sitting with, that their morning exercise session does not protect them from the biological consequences of the hours they spend sitting afterward. Exercise and non-sitting movement are not the same health variable. They address different biological processes. Both matter independently. In this video, we will examine what the BISPOS Annals of Internal Medicine meta-analysis found across 47 studies, why prolonged sitting produces biological damage through mechanisms that are distinct from and independent of what happens during exercise sessions, what the active couch potato phenomenon means practically for people who already have a disciplined exercise routine, and 3 practical and evidence-grounded takeaways about breaking up sedentary time that can be implemented without equipment, gyms, or significant disruption to a workday. Quick note before we begin, this is educational content based on published research, not medical advice. Talk to your physician before changing your regimen. Now, the study. For most of human evolutionary history, the problem of prolonged sitting did not exist at the scale it does today. Continuous desk-based cognitive work, long-haul travel, and screen-dominated leisure are recent developments in evolutionary terms. Most of human history involved near-continuous low-level physical activity punctuated by occasional high-intensity effort, not sustained stationary postures for 8 to 12 hours daily. Human physiology has not adapted to accommodate the contemporary sedentary environment, and the metabolic consequences of extended inactivity, distinct from the simple absence of vigorous exercise, have become an active focus of research only in the past 2 decades. The conceptual distinction between sedentary behavior and physical inactivity is fundamental to understanding this research, and it is a distinction that most health communication conflates. Physical inactivity refers to not meeting recommended exercise thresholds, not getting sufficient vigorous or moderate intensity exercise per week to derive cardiovascular and metabolic benefits. Sedentary behavior refers specifically to the time spent in low-energy activities during waking hours, primarily sitting and lying down when energy expenditure is at or near resting levels. These are related but measurably distinct behavioral dimensions. A person can exercise 45 minutes in the morning, meeting the weekly exercise recommendation, and still accumulate 10 or 11 hours of sitting in the remaining waking hours of that same day. By the definitions used in sedentary behavior research, that person is both physically active and highly sedentary simultaneously. These are not contradictory states. They are independent behavioral dimensions with independent health implications. For adults over 55, this distinction is particularly relevant because the structural features of later life tend to increase sedentary time regardless of exercise intentions. Retirement removes the ambulatory movement, the walking to meetings, the standing at whiteboards, the stairwell climbs that was embedded in a workday without being counted as exercise. Reduced commuting eliminates the walking that commutes involved. Increased leisure screen time, recreational reading, and extended television viewing replace more active retirement activities. Health conditions that cause pain or reduce mobility create additional barriers to non-exercise movement. A former professional who retires and adds a 45-minute morning walk to their schedule may actually become more sedentary in total waking hours than they were during their working years, when ambient movement was higher. The physiological mechanisms by which prolonged sitting produces harm independent of exercise volume are increasingly well characterized. Lipoprotein lipase, an enzyme essential for clearing triglycerides from the bloodstream and transporting fatty acids into tissue, is dramatically suppressed in inactive skeletal muscle. When large muscle groups in the legs and trunk are inactive for extended periods, this suppression reduces the body's capacity to clear circulating lipids between exercise bouts. Glucose clearance is similarly impaired during prolonged inactivity, as the GLUT4-mediated glucose uptake that is stimulated by muscle contraction ceases. Endothelial function in the lower extremities, the capacity of blood vessel walls to dilate appropriately in response to blood flow signals, is measurably impaired by extended sitting due to reduced shear stress on the femoral arteries. Chronically elevated insulin levels result from reduced peripheral glucose disposal. Each of these mechanisms operates continuously between exercise sessions, producing biological consequences that accumulate independently of what happens during the exercise bout itself. A study published in the Annals of Internal Medicine by Biswas and colleagues conducted a systematic review and meta-analysis of 47 studies examining the association between sedentary time and health outcomes in adults. The outcomes tracked across the included studies covered the health consequences most relevant to the 55-plus population: all-cause mortality, cardiovascular disease incidence and mortality, cancer incidence and mortality, type 2 diabetes incidence, and hospitalization rates. This was a deliberately broad outcome sweep, designed to capture the full health consequence profile of sedentary behavior rather than focusing narrowly on any single disease pathway. The studies included in the review used two types of sedentary time measurement: device-based measurement accelerometers worn on the wrist or hip that objectively record periods of low acceleration, which are used as a proxy for sedentary posture, is more accurate and less subject to reporting bias, but was less common in older studies due to the recency of wearable measurement technology. Self-reported sedentary time from questionnaires, asking participants how many hours per day they typically sit, is less precise and subject to recall bias and social desirability effects. People tend to underreport sitting time, but was available across the larger historical evidence base. The review included both measurement approaches and examined whether measurement type affected the magnitude of the observed associations. The populations represented in the included studies were primarily adults in North America, Europe, and Australia across multiple age ranges, with sufficient representation of adults in their 50s, 60s, and 70s to make the findings relevant to this channel's core audience. Study follow-up periods ranged from 2 to 14 years, providing mortality data across observation windows long enough to capture meaningful event rates. Critically, the review was specifically designed to test whether sedentary behavior's health effects were independent of physical activity, the key methodological question that distinguishes this meta-analysis from earlier work that had simply shown that sitting time was associated with poor health outcomes without establishing independence from exercise. To test this independence, the analyses either statistically adjusted for physical activity levels or examined sedentary time effects within stratified categories of physical activity, comparing the mortality rates of active people who sat a lot to active people who sat less, and inactive people who sat a lot to inactive people who sat less. This was the methodological approach that directly produced and confirmed the active couch potato finding, and it required studies that had measured both sedentary time and physical activity in the same participants, a requirement that was met in a subset but not all of the 47 included studies. The researchers reported that prolonged sedentary time was associated with a 24% increase in all-cause mortality, a 91% increase in cardiovascular disease mortality, a 17% increase in cancer incidence, and a 90% increase in type 2 diabetes risk across the included studies. These are substantial effect sizes that place sedentary behavior in the company of recognized major health risk factors. The cardiovascular mortality finding, a 91% increase in the most sedentary compared to the least sedentary groups, is particularly striking and deserves careful contextual framing. This is not a marginal statistical association. A 91% increase in cardiovascular mortality risk, if the association were causal and applied uniformly, would make sedentary behavior one of the most consequential modifiable cardiovascular risk variables identified, comparable in relative risk magnitude to major established factors. It is important to note that this is a comparison between extremes in the sedentary time distribution, the most sedentary group versus the least sedentary group across studies, and the absolute risk increase for any individual moving from average to somewhat less sedentary would be considerably smaller than this extreme comparison suggests. What the researchers found next is even more important for this age group. The interaction with physical activity was the central finding that set this meta-analysis apart from earlier observational data on sitting. The analysis confirmed that the associations between sedentary time and mortality were present even among adults who met physical activity guidelines, specifically, adults who were getting the recommended 150 or more minutes per week of moderate aerobic activity. In people who were both physically active and not excessively sedentary, the risks were lowest. In people who were physically active but also highly sedentary, the active couch potato pattern, the mortality risk was intermediate and significantly elevated above the active, non-sedentary group. In people who were both inactive and highly sedentary, the risk was highest. The evidence clearly pointed toward two independent behavioral dimensions, exercise volume and daily sitting time, that each contributed independently to mortality prediction. The study also found evidence for dose response within the sedentary behavior dimension. Longer daily sitting time was associated with progressively higher mortality risk, with the steepest portion of the risk curve appearing above approximately 8 to 10 hours of daily sitting. Given that the average American adult spends 6 to 8 hours per day in sedentary behaviors, and that retired adults whose structured workday movement has been removed may sit considerably more, this threshold is not a theoretical extreme. It is a description of the actual daily reality for a substantial proportion of the 55-plus population. The limitations of this evidence deserve honest examination. Meta-analyses of observational studies aggregate correlational data, and the sedentary behavior literature faces several methodological challenges that deserve direct acknowledgement rather than being glossed over in favor of a clean narrative. Self-reported sedentary time, the primary measurement approach in the majority of included studies, is subject to systematic recall bias and social desirability bias. People consistently underreport how much time they spend sitting when asked to estimate it retrospectively. This underreporting means that the exposure estimates used in these studies are likely inaccurate, and the true dose-response relationship between sitting time and health outcomes may be different, potentially stronger or differently shaped, than the reported associations suggest. Device-based accelerometer studies are more objective, but they carry their own limitations. Accelerometers classify low-intensity movement versus sedentary posture based on acceleration thresholds. They cannot reliably distinguish sitting from standing still, which are metabolically similar but may differ in vascular consequences through hygrostatic pressure and other mechanisms. A person standing motionless for an hour may register similarly to a person seated for that hour on some accelerometer algorithms, even if the cardiovascular outcomes differ. Residual confounding is a persistent concern in this literature. People who sit the most may be more sedentary because of underlying health conditions, chronic pain, mobility limitations, depression, heart failure, or musculoskeletal disease that independently elevate mortality risk. Even after adjusting for measured health status variables, unmeasured disease burden in highly sedentary individuals may partially explain the mortality associations. This residual confounding cannot be fully eliminated in observational data. The 91% cardiovascular mortality increase should be understood as a comparison between extreme groups in the sedentary time distribution across heterogeneous studies, not as a statement about what any individual would experience from incrementally reducing their sitting time. The relative risks compare the highest to the lowest sedentary categories, which are defined differently across included studies and likely represent very different absolute sitting time thresholds. The marginal benefit of reducing daily sitting by 1 or 2 hours from a moderate sitting baseline is not 91%, it is a considerably smaller effect that the extreme group comparison cannot precisely quantify. There's a catch that matters specifically if you're over 55, the optimal intervention parameters for breaking up sedentary time, specifically how long the break should be, what type of movement is most effective, and how frequently breaks need to occur, are still under active investigation. Brief walking breaks, standing, light stretching, and low-intensity ambulation have each been studied in short-duration laboratory trials, with results consistently suggesting that any movement interruption is metabolically superior to uninterrupted sitting, and that the frequency of interruptions may be as important as the intensity or duration of the break activity. 3 practical takeaways from the BISFOS meta-analysis for adults over 55. Takeaway 1. Interrupt sitting every 30 to 45 minutes. The evidence on sitting breaks consistently points toward frequency of interruptions as the meaningful variable, not the intensity or duration of the break. A 2-minute low-intensity walk every 30 minutes does not accumulate meaningful aerobic intensity, but it prevents the progressive metabolic suppression, particularly suppression of lipoprotein lipase in inactive leg muscles and decline in femoral artery endothelial function, that accumulates during sustained sitting. Implementation requires no equipment, a phone timer set to 30 minutes, a habit of standing when switching tasks, standing during phone calls, walking to another room during cognitive pauses. The goal is interrupting sustained inactivity regularly, not achieving any particular movement volume during breaks. Takeaway 2: treat the weekly exercise session and daily distributed movement as two separate health ledger entries, because the BISPOS data shows they are. An hour of Zone 2 aerobic training on Monday morning produces cardiorespiratory and muscular adaptations. It does not restore lipoprotein lipase activity during the 11 hours of sitting that follow. Both behaviors need to be present. Zone 2 training, resistance training, and distributed movement interruptions address different biological processes. All three belong in the health picture, none substitutes for the others. Takeaway 3: be realistic about what standing desks achieve. The evidence shows modest benefits, some reduction in sitting time, some favorable effects on glucose metabolism. But standing still is metabolically much closer to sitting than to walking. Prolonged static standing also creates musculoskeletal load on the lower limb joints and lumbar spine, a real concern for older adults with existing joint conditions. The evidence most consistently supports actual movement interruptions over postural changes. A 30-minute timer with 2 to 3 minutes of walking per break requires no equipment and has the most direct mechanistic support in the sedentary physiology literature. The BISPOS meta-analysis of 47 studies makes a compelling and methodologically serious case that sedentary time is a health risk dimension that is distinct from physical inactivity, one that is not fully offset by meeting exercise guidelines, and one that carries substantial mortality associations at high daily sitting levels. For adults over 55, the practical implication is a two-entry health ledger: structured exercise on one line, distributed movement interruptions on another, with both lines needing to be filled. Adding a 30-minute timer protocol to interrupt sitting, whether during a workday, a reading session, or an extended home period, is a low-cost, low-barrier behavioral change that addresses a biological risk dimension the exercise session cannot fully cover. The PDF guide on reading your biomarker panel, linked in the description, includes the metabolic markers most affected by chronic sedentary behavior, including fasting insulin, fasting triglycerides, and the HOMA-IR insulin resistance metric, which can serve as practical tracking tools for evaluating whether behavioral changes are producing measurable metabolic improvements. Subscribe to stay current with this evidence-based series as we continue building the framework for longevity health after 55. This is educational content, not medical advice. Always consult with your physician before changing your regimen. Studies are preliminary, individual responses vary.